Good afternoon all students. Yesterday we have learned with the NEET of the 8th chapter and we have completed them. So today we will discuss the 9th chapter biomolecules. As you know that in organisms, each and every organism it is made up of chemical components. As you know that during the evolution, the first life was originated on the earth. At that time chemical evolution occurred there, and due to the chemical procedure, the first life was generated on the earth. So each and every organism consists particular any type of the chemical. Basically when you identify that carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and out of this all these chemical components, find carbon is present in the most abundant amount. Carbon is present in all organisms in most abundant amount. Fine. Out of this, all these chemical components, carbon is present in most abundant amount. How we isolate or how we analyze the chemical compositions? As you know that we can take the small specimen of the tissue or any living thing, and then we can add the trichloroacetic acid. So trichloroacetic acid is weak acetic acid that by using trichloroacetic acid is a weak acid using mortar or pestle. We can properly mix the living tissue with the trichloroacetic acid there. Now, you know that with the help of cheesecloth as well as cotton, we can filter this slurry there. So filtrate, it is from there, is known as acid soluble pool, whereas other portion, the retenant there, it is known as acid insoluble pool. So acid soluble pool consists thousands of organic compounds. Okay, acid soluble pool consists thousands of organic compounds whereas acid insoluble pool contains protein, nucleic acid, polysaccharides, etc. Fine. So here biomolecules are of two types. As you know that we can measure the biomass or the molecular weight in the unit of the Dalton. So biomolecules are of two types: micromolecules, which are acid soluble, okay, micromolecules are acid soluble and consist 18 to 800 Dalton weight. Okay, 18 to 800 Daltons molecular mass. And here amino acid, sugar and nucleic acid are the examples. Amino acids, sugars and nucleotides. Okay, are the example of the micromolecules. Whereas another one is macromolecule, which is acid insoluble in nature, Daltons and above. Okay, molecular mass more than 5. Polysaccharide, protein and nucleic acid are the examples of it. Polysaccharide, nucleic acid and proteins are the examples here. So lipids are not macromolecules. because their molecular weight do not exceed 100 dalton, but they come under the macromolecular fraction because it consists more than 10,000 dalton molecular mass. Acid insoluble acid soluble fraction represents roughly cytoplasmic composition without organelles. Whereas acid insoluble fraction represents macromolecule of the cytoplasm and cell organelles. So here acid acid soluble fraction, it forms the cytoplasmic compositions without these organelles. So in cytoplasm the ionic components, inorganic components, orbital composition, it is acid soluble fraction there, whereas acid insoluble fraction represents the macromolecules of the cytoplasm as well as organelle. So here these two are combined together and form the whole chemical composition of the cell or the organism. So here micromolecules less than 1000 Dalton molecular mass, macromolecules greater than 1000 Dalton, 10,000 Daltons and above. So in between that, so many molecules are noticed there. In your textbook, one line is given there, the ash. When the tissue is fully burnt, and at the end of the burning procedure, the remnant known as ash, and in the ash, calcium and magnesium like inorganic elements are present there. This is the most important line. It is given there. The basic composition of the all living tissue. Basic chemical composition of all living tissues is C, H, O and N. So basically carbon, hydrogen, oxygen and nitrogen all are present in the basic elementary components there. Now, let us discuss in detail. So, remaining primary metabolites, secondary metabolites are already given in your textbook. So, you refer this one. Not much more portion other than the textbook fine. So, now let us discuss with the carbohydrates. Carbohydrates, in other ways, you say that sugars. Basically, fine. See, few points are there. Main source of energy. In our body, carbohydrate, protein, lipids are present there. Basically, we obtain the energy from the carbohydrates. So, first prime respiratory substrate. First, respiratory substrate is carbohydrate. So basically in our body, carbohydrate, protein, lipid there. So out of this, all these molecules, we immediately obtain the energy from the carbohydrate. Basic components are C, H and O. Okay? Carbon, hydrogen and oxygen. Basically here hydrogen and oxygen both are present in 2:1 ratio. CH H2OY, or you say that CN H2OM, whereas N is equal to M also, as well as N does not is equal to M also. But majority here in most of the sugars N is equal to M. Fine, this one is wrong for few sugars, so majority N is to M, so common formula is this CnH2OM, but in few cases N is equal to M, sometimes N does not is equal to M. So here monosaccharide, disaccharide, oligosaccharide and polysaccharide, there are 4 types of carbohydrates are there, but here H and O present in 2:1 ratio. But it is not water, understand? Okay, CnH2OM, whereas N is equal to M, majority N does not is equal to M. Fine, but both are different also there. So another point does not is equal to 0. Okay, carbon, hydrogen and oxygen, 3 components are present here. So here 4 types of carbohydrates. First, monosaccharide. So only one sugar, basic sugar is there. Monosaccharide, disaccharide, oligosaccharides. Actually, oligosaccharides are larger than the di, but smaller than the poly. So third is oligosaccharide and fourth is polysaccharide. Many number of molecules are present there in numerous. So oligosaccharides are larger than the disaccharides, but smaller than polysaccharide.